Okay. Um, in Khan Academy, the lessons for today are basically something I've already been covering with you. Uh, the lessons for today are considered the more complex ones, where you join together multiple properties, like multiple rules. So let's say you have a product rule that part of the product rule involves chain rule. That would be like a combination of the different rules together. And I've already purposely been doing some of those with you because I don't think it always helps to wait to look at difficult ones. If you only work on easy ones, it kind of gives you a false sense of security is a bad way of wording it. It makes you feel like you're doing a lot better when in reality you need a lot more practice at it to be good. So I've already kind of been giving you those today. And that's why I thought this 45 minutes for Friday would be good for us to go over the outline for the Chapter 3 test. This is kind of what I want to highlight right here. So normally, I really don't care when you take the test. I mean, it really doesn't matter to me. But they have a ridiculous deadline for us to turn in grades for this Hexmester setup. And to be honest, I think that's partly why they added that work day for teachers on that Monday. Because it's really difficult to get things, like calc things are tough to get graded sometimes. I think it'll go okay for this one, but regardless, you're going to need to take it during your class hour on the 13th, on that Tuesday. I definitely don't always see this class, here at 8:30. Do know that's when I want you guys to take it. So I'm trying to let you know ahead of time so that you can plan for that. Now, I do want you on Google Meet while you're taking the test, but I get how a lot of your connection lags or, things happen where all of a sudden it just drops you out of Google Meet half the time. So I get that. I would prefer you to be on Google Meet just so that you can ask questions about the test while you're there, etc. Now they did add a new thing in Google Meet where I can individually, what do they call it, a pull-out group? So basically, like if one of you has a question on the test, instead of you just like flat out asking it to everyone, I can create like a separate little room with just us two so that you can ask me a question for the test or ask me a question on anything, that won't be like just in front of the whole class. That's the 14th. Yeah, the 13th is the Tuesday. The 14th on the Wednesday is when you're taking everything. And that's basically when I'm able to grade things. So that's why I needed everybody to take it on the 13th. And honestly, I don't think you guys taking the test at that point is going to be a big deal for most of you. Here's what I expect to be the big deal for most of you is Khan Academy work. A lot of you will really procrastinate that badly. Like, it'll be on the recording if I go screenshot it. If I went and took a screenshot right now of my class as a whole in Khan Academy where you're at, 4 people are at 60%, which is kind of where you're supposed to be at. I've got 62 people behind. And that worries me a lot. So the reason I'm really trying to emphasize to you today that Tuesday is the cutoff. Okay? Tuesdays is when I'm going to grade everything. Wednesday morning when I wake up, that's when I'm going to put the grades in the grade book. A lot of you really want to put off and procrastinate your work. I'm not much different. I mean, I get it. That's exactly what I used to do all the time. So I'm trying to tell you now, don't do that because everything just ends super fast this trimester. Julia, go ahead. Yes and no. So I wait till everybody gets done with it to find out where you ended at. And my goal is I want 2/3 to 75% of everybody to be in the A range for homework. So I want 2/3 to 3/4 of everybody to be 90% above in Khan Academy. And so far it has, honestly, I wouldn't have needed to add points to you for Unit 1 when I expected to, but I wasn't going to like take it back and change it. So I left that. Unit 2, it worked out really well that's pretty much where everybody was. But I'm just going to look at it chapter by chapter. So my goal is to make sure that you guys have most of the points in the homework if you're doing everything you should. Now, there's a bunch of people that haven't even like done any of the work. And so in that case, I'm not going to keep them in mind, but yes, if you guys do what you're supposed to do, that's my goal. Anybody else have any kind of questions about the test, the homework, layout, all that kind of stuff? I didn't put a timer on it. I didn't think I would need to be honest. I purposely made the test shorter so that no matter what, everybody be able to finish during the class hour. Because I honestly have zero idea who's actually in the classroom any which day. So I just left no timer on it because I don't think it's going to matter. And I know some of you guys for whatever reason, get a lot of anxiety for timers. Like if there's a timer in the corner, it kind of makes you feel like everything's going faster. So yeah, I don't think time should be an issue, but yes, during the class hour. Oh, you can just figure it out with me. That's not a problem. Maybe. I can talk to you about it individually just so we can figure out a good time. Yeah. Yeah, it's not so much about it's just to make sure everything's done. Great. Okay. Yeah, we can figure it out. That's kind of why I wanted to tell everybody ahead of time so you can find out last second. So I thought we should just go over the 12 questions. Now, there's only one question on here that you haven't done yet, and that's question number 12, the second derivative, which we're going to go over together on Monday. And second derivatives aren't difficult. I mean, I can just tell you right now, it's the derivative of a derivative. So it's not difficult to do. It's just you have to understand what that means. But that's the only one we haven't done. 1 through 11, we have done together already. And like I said, I purposely tried to plan this one so that time wasn't going to be an issue for you guys. I was actually really happy with how fast everything went on the last test. Because like I said, I wasn't sure how fast things were going to go for you typing in the computer. It seemed like it went pretty well. So number 1, derivative of a composite function, chain rule, multiple choice. So if you are taking notes of any style, a composite function, so if that term is used, that usually means it's something like this. Now this is kind of like the real definition of chain rule, and often it can look more confusing, but it's exactly what chain rule is. I want to try to make sure I call people I haven't called out before. Philip, do you think you could help me out? How do I take the derivative of this? Maybe? I'm not sure if I understood what you meant out of it. I'll write it down. I'll write it down. You might... No, that's all right. You might have meant it correct. It's very hard to describe sometimes. So if this is a composite function, the derivative of a composite function is going to be f prime of g of x times g prime of x. This is what the chain rule is. The chain rule says that you do the derivative of the main function, and then you do the derivative of the one that was inserted. Now there's a billion ways that composite functions and chain rules can look. I'll just put a common one that we usually have done together. One of them could be sine of x cubed. Sine of x cubed. Let's go with, I don't know, u king. So I'm not asking you how to take the derivative. Here's what I'm actually asking you. You guys had some questions in Khan Academy where you had to identify which one of these was f and which one of these was g. Like up here, how it says f of g of x. If I have sine of x cubed, oh, go for it. Perfect. And that's because the x cubed was essentially put into sine of x. So g of x is x cubed. Sine of x is f of x. So you guys are going to have to identify which one is f, which one is g. That's one of these questions. It might actually be question 1. I don't remember which one is which there. Oh, actually, it can't be 2. Number 2 is a table. So maybe I should fix that arrow. But do know that that's what style number question 1 is. You're going to have to be able to identify, how to do chain rule from f of g of x, and how to identify which one is f, which one is g. Number 2, where it says composite from a table. Now, what that's going to be is it's still going to be this same question, the overlying f of g of x, that the derivative of f of g of x is f prime of g of x times g prime of x. But you're going to have a table, and the information in the table, is going to be f, g, f prime, g prime. And I know you had questions like this in your homework, where you're given some numbers for each one of these, and you don't know the equation. You just know the number answers. And you're going to have to plug the number answers into the correct spots. So, like, figure out g of 2. Answer would be right there. And then whatever that answer is, you're going to have to do f prime of that number times g prime of whatever. You're going to have to be able to use this table to fill out these answers. That's what question 2 is. Question 3 is just a normal question, so it's free response. So question 3, let me just make one up. We'll do it together. Let's do 4 times 8 minus x cubed to the 5th power. We'll call that f. That's a terrible f, but we'll call that f. And John, can you help us figure out how to do the derivative of that? Okay. Close. So the 4 is a scalar multiplier. So automatically this 4 goes down into the derivative. So scalar multipliers don't affect the derivative itself. What you're going to focus on is you're going to focus on this. This is the actual function we're working with that we're going to take the derivative of. Now, if you like to do it where you identify f of x and g of x, or, yeah, the inner function is 8 minus x cubed. The outer function is x to the 5th. I know everybody does it slightly different. So your idea was okay there, John. I mean, like, that's no problem. I have a feeling a lot of people in here would do this as like u substitution. So in their head, it's u to the 5th. And the derivative of u to the 5th would be 5u to the 4th. So 5u to the 4th times du. And then the derivative of u would be negative 3x squared. And then this can definitely be simplified, but this is the derivative of f. So we would have 20, we would have negative 60x squared times 8 minus x cubed to the 4th. That would be, this is a, obviously the question could look very different for number 3, but the idea for number 3 is that you're going to be using chain rule. And then to clarify, in case you weren't sure, this is how I would love for you guys to show work. I guess I just rewrote. You don't have to write this as the work. But if you guys are showing work, this is what I would like you to write for one step. And then this would be what I'd like you to write for the bottom line as your final answer. Because this would absolutely tell me exactly what you did on the problem. So that one I would definitely like the negative 60, only because you had 3 different regular multipliers that could all go together. So those are what I would consider an obvious put together type simplification. If you lose anything, you would lose very little points. How's that? I don't have a great answer other than to tell you you're supposed to simplify what's supposed to go together. I know some students where they have trouble is they end up simplifying too far and then make mistakes because they kind of feel like they're supposed to simplify forever. Undersimplified is better than oversimplified because oversimplified means you got something wrong. So if you're not sure, just play it safe. Derivative of an exponential with a chain rule. This is one of the questions that I didn't get a chance to do with you in person, but was part of the homework. So an exponential with a chain rule, if I make one up on the spot here, would look something like 8 to the power of x squared plus 1. Now we want to take the derivative of that. So this is considered an exponential because we have a numeric base and a variable exponent. Let's see. Chidera, do you think you could help me out on this one? Okay. That's definitely being honest. Appreciate it. That does remind me. I mean, not that your answer reminded me of it. I was about to say it, but I didn't want to cut you off. Make sure you guys are making, note cards, cheat sheets, whatever you want to call them. Make sure you're making them with all the little formulas you need for this unit. I mean, that would be really helpful. Okay, so Jadera, do you want me to give you like the generic formula, and then maybe you can help me out? Okay, so if we have a to the variable power, so a means a number, u means a variable power, the derivative is going to be ln of a times a to the u times the derivative of u. %, perfect. Nice job. Yep. So that's what kind of reminded me to tell everybody about the cheat sheets, because this one's not difficult to know to do if you have the formula, but remembering the formula is definitely hard for a lot of people. I mean, they're not always straight. Like this one's weird. It's just not straightforward at all. Does anybody have the formula in front of them? I feel like I'm remembering this one wrong. Is this correct? ln of a? It's not 1 over ln of a? I think 1 over ln of a must be the integral, not the derivative. Oh, Lauren, I thought you were backing me up. Oh, okay, perfect. Perfect, thank you. Remembering, oh, go ahead. Oh, no, I know we multiply by du. So the thing I don't like about some formula cards, like looking up formulas, if your formula says a to the x, then that treats it as just a regular x. So the derivative of a to the x is ln of a times a to the x. And then it technically is times the derivative of x, which is 1. So if you guys are looking at formulas online or wherever, make sure you find the formulas that have a u or something there that represents whatever. So you're always going to multiply by the derivative of u at the end, though. Oops. No, I just wanted to make sure I wasn't misremembering the formula, because there's so many formulas in calc. Okay, so that was 4. Does anybody want me to go through number 5 with you, trig with a chain rule? Yes, okay. So trig with a chain rule. I don't know, let me make it as difficult as I can. Sine to the 4th of x squared. Why don't you guys see if you can figure out that derivative on your own? Take a minute or two to do that. We did one like it in class. So we did one like it in class where we did sine squared, I think. Okay. Here's where I'm guessing some people forgot. I would bet some people forgot about either cosine of x squared or the 2x at the end, because it's kind of easy to forget one of them. So here's how I do this in my head, or written down. So sine to the fourth of x squared. It technically means sine of x squared to the fourth. So in my head, I do u to the fourth power. And the derivative of u to the fourth would be 4 u cubed times du. So the 4 there, u, and then the cubed I write on the sign. So this is 4 u cubed, and then du I do as a separate problem. So kind of off on the side in my brain, I do sine of x squared as a separate problem. Sine of x squared is sine of u. The derivative of sine of any angle is cosine of same angle times derivative of angle. And so the du from the original pink one is cosine of x squared times 2x. And the final simplified answer, the 4 and the 2x go together. Basically, this is like a double chain rule. Now, these are the style questions that you're going to see today for Khan Academy. It's using more than one rule at a time. So we did power rule, chain rule, chain rule. Now, even though this is a shortened class today, I wasn't that worried if we didn't get through the outline today, because we still have Monday where we can go over part of the outline. Because second derivatives are definitely not going to take that long to cover on Monday. But please, I mean, I know you guys are pretty good at it lately here. Ask questions away when you run into something that doesn't make sense, or whatever. You don't have to wait for the end of the problem for me to ask if you have questions. Okay, so we did 1, 2, 3, 4, 5. 6, chain rule. Where is the mistake? Is there a mistake? I believe this was on Wednesday's homework. And that's what this section is called. Like, the assignment is, what is the mistake? Something like that. And so those questions, what they are, is an entire problem is written down, right? So this is step 1, step 2, steps 3, step 4, step 5. And then the question will say, which step has the error? And then, sometimes none of them have an error. It's correct. So that's going to be the question number 6. I did word it slightly different than Khan Academy because I don't like how Khan Academy words it, because it could be taken as meaning, let's say there's an error in step 4. Well, then kind of there's automatically an error in step 5 as well. So the way I worded it is I said, what is the first step there is an error, if there is an error? And then one of the choices is also there isn't an error. So that is question 6. Question 7, implicit differentiation with chain rule. You guys had one in your homework the other day that was, somewhat like this. So I'll just put this. So this was implicit differentiation with chain rule. Although this one wasn't really a chain rule, I guess, but whatever. The hardest part of this question is the first term. This is where I got most of the questions from anybody. So this first term, what you're going to do is you're going to treat it as product rule. 5x squared is f, y is g. And so you're going to do product rule on this. F, f prime, g, g prime. f would be 5x squared, g would be y. Derivative of 5x squared is 10x, derivative of y is dy dx. And then you're going to start putting those things in, minus the derivative of y squared, plus the derivative of y, derivative of 3. Now your goal is to solve for dy dx. So dy dx is in more than one spot. So you're going to have to combine those together and factor out dy dx. There's tons of steps. But these are definitely in your homework for you to practice. And I would highly recommend you do practice those. And I can certainly help you out with some of them if you want, but I would recommend you practice them. Whoa. Quotient rule. We've done a lot of quotient rules. Inverse trig derivative. So number 9 was your section on Wednesday. Maybe yesterday. This week has been an absolute blur. I think Wednesday. So, because Wednesday was the day I had to try to fit 2 lessons into one. And inverse trig derivatives are something like this when you are asked to find the derivative of arctan of x squared. No, whatever. It doesn't really matter. I believe you are responsible for knowing arcsine, arccosine, arctangent. Now, the arc terminology, I don't think you're familiar with. Your pre-calc textbook, I don't think used arc as a term. I believe your pre-calc textbook used the notation with the -1, like sine inverse. Sine inverse of theta is the same thing as saying arcsine of theta. Certain books and certain places use different terms for the same thing. Every calculator has the sine inverse button on it. It is exactly the same as arcsine. So on your note card, make sure you write down the formulas for the arc functions. I haven't a clue what the derivative of arctan is off the top of my head. It is not one that I ever use enough of to ever try to memorize. So it's something that I just look up. And to me, that's the ideal situation of the purpose of a note card or textbook. Okay, so there's inverse trig derivative. Number 10 is inverse derivatives, not trig. So inverse derivatives are when you are given a function. Trying to remember. I feel like we had one like this. No, it was 5. We did one together that I picked. I hate this. I'm trying to think of them off the top of my head. We'll go with it. And then you are asked to find the inverse derivative of a number. So in this case, I would pick like 6. And that's because I need this top equation to be equal to that number. I will tell you that I copied Khan Academy's and AP Classroom's notation. I did not write F inverse prime on the test. I wrote G. In the beginning of the problem, they say that F and G are inverse. That's how they start the problem off. And the reason they do that is this is telling you that G is F inverse. So instead of me saying F inverse prime of 6, in the problem, it's written as G prime of 6. So don't let the G throw you off. It's the same thing as inverse. Now these questions are kind of straightforward. They're just weird. and they're difficult to remember. So on your note card, I would either write the formula or I would write an example of one of these problems on your note card so that you have one with you to compare it to. But do know that this question is from a table. So that means you're going to have to get all of your number answers from the table. And so that would be the type of example I would write down. Number 11. Oh, you know what? Number 11 is actually from Mondays as well. So you don't know how to do this one technically yet. I can give you an example of what number 11 would look like. Number 11 would look something like this. What time is it? 40? Okay, I'll be done after this. No, that should be pi. So this is an alternative form of the derivative at a point. If I'm looking at this problem, in my head, I automatically know that the function that's being referred to is sine. And I know the point that it's referring to is pi. And that's because I see sine, I see pi. This plus h is just notation for the derivative. So that means what I would do is I would take the derivative of sine of x, which is cosine of x, and I would plug in pi. And what's cosine of pi? -1. So this is going to be finding a derivative from an alternative form of derivative at a point. I think in Khan Academy, I think the way they label it is other forms of a derivative, something like that, but it's on Monday's assignment. Okay, last tiny bit, and I'm basically done with the review.